Welcome back. This is part 2, Eco 501, sections 1 and 2, week 4. In this part, we'll do a very brief review of how to read a graph. For some of you, this will be a walk in the park. It will be very simple, basic tools that we're going to look at. For another group of among you, for two reasons. A, people fear maths. B, you may not have done this for some time. So it's just basic high school maths, so nothing to get worried about. So let us go to the slides. Okay, so this part, you can look at any book you like. It doesn't matter that you have to go at the part that we've referred, Stiglitz and Walsh, page 47 and to 50. Now, what we want to know how to read a graph, how to read a slope. Okay, so because we will be using these concepts a lot, and the basis of analysis is going to be just pure high school maths. Here we'll just review some basic things. Later on, we're going to become a little bit more adventurous and develop the tools later on. Now, a graph is a two-dimensional expression of a relationship between two variables. When we say two-dimensional, we're talking about a horizontal axis, we're talking about a vertical axis. So in both of the two axes, one variable is represented. By a mathematical convention, the horizontal axis is always the x-axis, and movement is read horizontally from left to right. If you want to ask why, the human brain is programmed to read left to right as a positive movement. The vertical axis is the axis where we plot another variable where movement is read vertically. The human brain again is programmed to read bottom to up as a positive vertical movement. So the graph is nothing but a two-dimensional expression of a relationship between two variables. Now, one thing before we get into further details, this relationship could be functional. Functional means one variable is independent that changes first. Second variable is dependent that changes after and because of the independent variable. So, or it could be just association. For example, there are many people in Bangladesh, so there are many deaths. There are many people in Dhaka city, so the consumption of bananas is very high. So these are causations, associations, which we define as correlation. Causation is what we are going to be interested in. So we have two axes, like we said, the horizontal axis, x-axis, and the vertical axis, the y-axis. Now, causations expressed as functions. This is nothing but y is a function of x. This is a general form. The form that we are using here is the form that we would like to use in economics, that quantity demanded is a function of price. Let's break it down verbally. The demand that I make is a function of price. The demand that I make depends on price. So price becomes the independent variable. What is the independent variable? The independent variable is the variable that changes first, the price. After that, once I as a consumer see the price, I determine how much demand I'm going to make, given the other factors that are in my hand. Similarly, if somebody said, no, we're not happy with QD, we want to see QS, supply is also a function of price. Of course, price is declared first, or we see the change in price. Based on that, firms decide how much to produce. So when we look at a causation in functional relationship, then we are actually combining a dependent variable with an independent variable. Independent variables by convention are always expressed on the right side of the equation, like over here, P is the independent variable. Over here, X is the independent variable. The dependent variable by convention is always expressed on the left side of the equation. Like over here, quantity demanded at a particular time. Over here, Y. Over here we have Y. Okay, sorry. The origin is the point of reference from which we make calculations. So if we are making, if we are looking at the horizontal axis, any movement to the right is a horizontal plus movement. Any movement to the left on the horizontal axis is a negative movement. This is how we are biologically programmed. Similarly, the vertical axis, any movement from going up is a positive movement. Any movement coming down is a negative movement. So the coordinate, when we write the coordinate, say point A, if we say 2, 3, that means it's 2 steps on the horizontal axis, 3 steps on the vertical axis. So when we write a coordinate, the coordinate always the first one is the independent variable. The second number is the dependent variable. This is a convention. And we write like this. Now we have 4 quadrants in a graph, but in economics, we are not interested in all the for all the 4 quadrants. Why? In economics, we don't experience negative price. Price may fall, but price will never be negative. We don't experience negative quantity. Quantity may increase, quantity may decrease, but we never see a negative quantity. Because of that, we focus only on the first quadrant. Now, moving to an example in your book, this is table 2.1. We have 2 columns here. One is DVDs, one is CDs. Now, if we want to visualize this whole matter, we are not introducing any price, nothing, just CDs, DVDs on one axis, CDs on another axis. Now let's see the next graph. We have DVDs on the x-axis, CDs on the y-axis. So the DVDs are basically the x-axis. So if we want, we can do a little, this is the x-axis, this is the y-axis. Okay, this is the x-axis, this is the y-axis. So now let's see. First of all, when we want to plot the points, we want to visualize the extreme points. What is an extreme point? An extreme point is when one of the 2 coordinates is equal to 0. I repeat myself again. An extreme point is when one of the 2 coordinates is equal to 0. What does that mean? That means is if the value of y is 0, what is the maximum x that we can get given our income? If the value of x is 0, what is the maximum y that we can get given our income? Let me repeat myself again. When the value of y is 0, then the maximum x that we can get is one intersection with one axis. Which axis? Correct, x. When the value of x is 0, then the maximum y that we can get is another intersection with another axis, which is the y-axis. So first of all, we get the 2 extreme points. Then this is the equation of a straight line. We just join them and then we get the function. So if all DVDs and no CDs, all DVDs and no CDs is this one. No CDs 0, all DVDs 6. So the maximum, the intersection point on the x-axis will be 6 units. If all CDs and no DVDs, then we have 12 CDs. So the other intersection point on the y-axis will be 12. Uh-oh. So as if there are 0 CDs, we have 6 DVDs. 0 CDs, 6 DVDs. 0 DVDs, 12 CDs. 0 DVDs, 12 CDs. Now, the objective of this was there is a ratio through which we can exchange a certain number of DVDs for a certain number of CDs. This is known as the slope. If we sacrifice one DVD over here, we get 2 CDs. If we sacrifice another DVD, we get another 2 CDs. If we sacrifice another DVD, we get another 2 CDs. So the ratio of exchange between DVDs and CDs, or more generally now, between X and Y is 2:1. How did we know that? Graphically, when we're looking at a ratio, we're looking at a ratio between the horizontal movement and the vertical movement. The horizontal movement we define as run because we are running along the horizontal axis. The vertical movement we define as rise. We're going up and down. The ratio of these two movements is known as the slope. So over here, as we move from point A to point E, what happens? At point A, we have 8 CDs. At point E, we have 6. So that's 6 minus 8 as we have moved from point A to E. The run is from 2 to 3. So what is the ratio? That's 2. The minus sign means is falling. The value in the 2 means 2 CDs can be exchanged for 1 DVD. If we are looking at the reverse one, then one DVD can be exchanged for 2 CDs, or 1 CD can be exchanged for half a DVD. So the math now, the important part of this video is that in mathematics, by convention, the independent variable is always on the horizontal axis, X. The dependent variable is always on the vertical axis, Y. Now, in our economics, what we have done, we have defined the demand function. Supply will be the same as quantity demanded is a function of price. So what happens is price is the independent variable. But in economics, we are going to put economics convention may change, and it will initially. The independent variable will not be on the horizontal axis. Independent variable will be on the vertical axis. Once we get into the graphs, this will be apparent. But the reason why I'm saying this is those of you who come from a mathematical background and are very familiar with graphs will find that what is vertical in mathematics will become horizontal in economics, and vice versa. What you saw horizontal in mathematics will become vertical because of a visual. We're making things upside down. That's why it's visual. Now, the next one is, what does the negative sign mean? It means that as we move from A to E, value of X is increasing from 2 to 3, and therefore 3 minus 2, but the value of Y is decreasing from 8 to 6, thus 6 minus 8. That's why we have a negative sign. Now the boundary points A and E, as we move from A to E, points on the boundary, point O. Now, A and D is a boundary point means that this is the best outcome. If we choose a point within the boundary, that means we are not doing the best we can given the situation we are in. We cannot go outside the boundary because our prices have been given externally. Our income is also set externally. That's why we can't go out of the boundary, but we can stay within the boundary. But doing so, we will not be exploiting the best situation that we are in. And this is basically what Stiglitz and Walsh mentioned in their the text or the summary that we discussed so far. Now, as we are doing reading graphs, we will be looking at these in detail during the discussion class, that what is a positive slope, why is it positive, this is zero, why this will become infinity or undefined in economics, this is negative, this is undefined in mathematics, but this will be zero in economics. I'm not going to do it here. I'm going to do it in the class to make it more transparent. Opportunity cost, this has already been discussed in week 2, that we can't choose two things at the same time because of scarcity. We have to make a choice. When we make a choice, we first make a ranking. Why do we do the ranking? We want to rank the best to the worst. Why are we doing best to the worst? Because we are trying to rank something that we like. If it was ranking of something that we didn't like, then the ranking would have been just reversed from worst to best, minimum to high, max. Okay. Then we make a choice. And what happens if the ranking was like this? Then C would have been the opportunity cost of choosing B. If the ranking is this, B, D, C, A, then D would be the opportunity cost of choosing B. Sunk cost is, once we make the choice, we enter a new environment. So whatever existed before we made the decision no longer exists. It's gone. That's why it's a sunk cost. Okay. Now, sunk cost we don't discuss in economics because we can't compare. Now that we are in BRAC University, we cannot compare BRAC University with the choices that we had before. That's why we don't discuss sunk costs. However, behaviorally, we do discuss sunk costs. Okay, but how we do that, we will discuss later on in the course. The next concept that we are going to do in detail is called marginal costs. So marginal cost means we're making a decision at the margin. What does that mean? We're making the decisions incrementally. When we consume water, we don't consume 10 glasses of water in one sitting. We consume one, then we decide, do we consume the next one? After consuming 2 glasses of water, we decide, will we consume the next glass of water, the third one? Now, marginal decisions, like we said, we're all doing net calculations. So if we want a benefit by going from 0 to 1 units, we have to pay a cost from 0 to 1 units. This is marginal benefit and marginal cost. If we find in our decision making the additional benefit is more than the additional cost, then our net function is positive. We say yes. If we find that the additional benefit is less than the additional cost, marginal benefit is less than marginal cost, we say no. If we find that marginal benefit is equal to marginal cost, then we are indifferent between the two. That is a definition of equilibrium. That is a definition of an efficient situation. During the discussion class, we're going to look at various dimensions of these 3 conditions: marginal benefit greater than marginal cost, marginal benefit less than marginal cost, marginal benefit equal to marginal cost. Now, when we do marginal benefits and marginal costs, we also come across a concept called average. I'm not going to get into a lot of details because this is not the course. You've done mathematics and basic statistics. Otherwise, you wouldn't have been nominated for this course. I'm going to compare marginal as GPA, average as CGPA. What is a GPA? A GPA is your average performance in one semester. Now, that semester could be the first semester, 0 to 1. That semester could be the second semester, 1 to 2. That semester could be the third semester, 2 to 3. Now, when we say GPA, we're talking of a single unit, first, second, third, and so forth. But as we move from first, second, and third, another average is also changing, and that average is our CGPA. How do we calculate CGPA? We calculate CGPA for integer units. If we say 2 units, 2 semesters CGPA, then we are calculating from 0 to the end of the 2 semesters. If we say what is your GPA in the second semester, second, not 2 semesters, then we are making a marginal decision. We're going from beginning of one unit to the end of another unit. So the second semester would be the end of first semester to the end of second semester. So once we finish one semester and we finish the 2 semesters, that particular unit is the second semester. But whatever performance we do in our second semester also influences our GPA, CGPA from 0 to 2. What we're going to look at is if GPA increases, then CGPA also increases. If GPA falls, CGPA falls. If GPA remains unchanged, then CGPA is also unchanged. Again, this will be the efficient unit. Now, GPA and CGPA is not what we're discussing. We're discussing marginal. So marginal change is the change that happens first. Whatever your performance is in that particular semester, GPA, that performance influences your performance in the average. That means the CGPA. So if marginal is increasing, then average will also be increasing. If marginal is decreasing, average will also be decreasing. If marginal remains unchanged during a particular semester, your CGPA, that means your average will also remain unchanged. These concepts we'll discuss in detail later because we're going to introduce cost functions and other concepts. We just keep this notion into our in our system for the time being. So if you've watched the video to this part, we've come to the end of part 2, and later on we're going to look at part 3. So see you all later. Bye.